Hello everyone. In this lesson, let's study belt drive technology and its application. We will study from three aspects: overview of belt drive technology, ordinary belt drive, and synchronous belt drive. Through the study of this class, I hope that everyone can master the basic principles of belt drive technology and understand the application of belt drive in mechanical equipment. You should be able to correctly select the type and specification of the belt drive according to the design requirements of the transmission system, reasonably configure the relevant components, and complete the design and debugging of the belt drive system. This aims to cultivate everyone's rigorous work attitude in engineering practice, enhance the ability to solve practical engineering problems, and at the same time stimulate everyone's thinking of innovation and optimization in the field of belt drive technology. First of all, please watch a dynamic video on the slide. Okay, we have roughly finished watching the dynamic video. Then, when observing these devices in the dynamic video, have you ever thought about why the crankshaft of the engine can drive the water pump to rotate? Why can the drum of the washing machine rotate at a high speed? How is the power transmitted? What problems will occur if directly using metal gears for rigid connection? Then let's think about what problems will occur if we directly use metal gears for rigid connection between the engine crankshaft and the water pump, or between the motor and the washing machine drum. First of all, the direct rigid connection method may lead to the following problems. 1. The meshing between metal gears may generate great impact and vibration, especially during high-speed operation. Excessive impact will lead to the wear of the gears, and even damage, affecting the service life of the equipment. 2. Without appropriate buffering devices or transition mechanisms, the rigid connection will cause the load of the transmission system to be too large, increasing the wear of mechanical components, thus affecting the stability and durability of the overall system. 3. The direct rigid connection method may not be able to absorb the fluctuations and differences in the power transmission process well, resulting in unnecessary energy loss and affecting the efficiency of the system. In the subsequent study, we will deeply discuss the principles, advantages and disadvantages, and application scenarios of these transmission methods, so that you can better understand their important roles in different devices. Next, we will further analyze the structure, working principle of the belt drive, and its wide application in modern mechanical equipment. First of all, let's understand the overview of belt drive technology. Belt drive is an important form of mechanical transmission. With the improvement of industrial technology and the increasing demand for the precision, lightweight, etc. of equipment, its application and transmission forms are becoming increasingly rich. The transmission belt has transformed from a traditional vulnerable part into a functional part. Its types have developed from ordinary V-belts and flat belts to narrow V-belts, synchronous belts, etc., and are widely used in fields such as automobiles, machinery, and textiles, having a profound impact on the national economy and daily life. With the diversification and performance improvement of the transmission belt, new materials, new technologies, and new processes are constantly being applied, and production equipment and detection means are becoming more and more advanced. China's rubber belt industry has formed a complete system, and its technical level and scale have been greatly improved during the 11th five-year plan period, promoting the development of the market and related industries. Now, let's learn about the relevant knowledge of ordinary belt drive. Ordinary belt drive can be divided into flat belt and V-belt drive. Its advantages are smooth transmission, simple structure, low cost, and convenient use and maintenance. It has good flexibility and elasticity and can adapt to large center distance transmission. The disadvantages are inaccurate transmission ratio, short belt life, large load on the shaft. The external size of the transmission device is too large, and the efficiency is low. And it is only suitable for the situation of large center distance, medium, and small power. Belt speed V equals 5 to 25 meters per second, and I less than or equal to 7. In addition, there are 5 points to note for ordinary belt drive. When installing, the center distance should be reduced, the tensioner should be loosened, and then adjusted after installation. Pay attention to the model and reference length of the V-belt. The center lines of the two pulleys should be parallel. The pulley section should be perpendicular to the center line. The groove wheels of the driving and driven pulleys should be in the same plane, and the deformation of the shaft and the shaft end should be small. Check regularly. V-belts of different types, produced by different manufacturers, and of different degrees of aging are not suitable to be used in the same group. Keep it clean and avoid exposure to acids, alkalis or oil stains to prevent the belt from aging. Next, let's continue to learn about synchronous belt drive. Let's first understand its definition and basic principle. The meshing type belt drive, also known as synchronous belt drive, as shown in the picture, transmits motion through the meshing of the transverse teeth on the inner surface of the transmission belt and the pulley teeth. Compared with the friction type belt drive, its characteristic is that there is no relative sliding between the pulley and the belt, which can ensure a strict transmission ratio, but it has higher requirements for the center distance and dimensional stability. Then let's familiarize its structure and material characteristics as follows. The performance advantages of synchronous belt transmission are as follows. The transmission ratio can reach 10, the efficiency can reach 98%, the slip is small, the structure is compact, and the operation is stable. No lubrication is required, there is no pollution, and the noise is low. It has excellent wear resistance and a longer service life than the friction-type belt drive. After learning about its performance advantages, let's take a look at its main disadvantages. High requirements for manufacturing and installation accuracy, and strict requirements for the center distance. Let's discuss its application scenarios. It is widely used in medium and small power scenarios that require an accurate transmission ratio, including automobiles, machine tools, textile machinery, chemical equipment, tobacco processing, food machinery, industrial transmission systems of instruments and meters, etc. Please carefully understand the requirements for the storage and installation of synchronous belts with me. 1. During transportation, the synchronous belt is strictly prohibited from being bent, otherwise it will cause the tensile layer to break. There is a minimum allowable bending diameter for the synchronous belt. 2. The belt should not be stored in an abnormal bent state for a long time. 3. The synchronous belt should be stored in a dry place and avoid direct sunlight. 4. When installing, the center distance should be shortened, the tensioner should be loosened, and the belt should not be forcibly pulled and dragged from the pulley guard to be installed. 5. The teeth of the pulley must be at a right angle to the running direction of the belt. 6. The parallelism of the main shafts of the driving and driven pulleys should be controlled at about the tangent value 10 equals 1,000th. Incorrect shaft position will directly affect the service life. 7. If it is found that the belt on the driving pulley is pulled to one side, the driven pulley should be moved for adjustment, and the pressure of the tensioner should be adjusted. 8. During startup, if the center distance changes, the belt becomes loose, and the phenomenon of tooth skipping occurs. It is necessary to check whether the pulley frame is loose, and whether the shaft positioning is inaccurate, and make adjustments and reinforcements. 9. When installing the synchronous belt, an appropriate tension force should be applied according to different models and belt widths. 10. The tensioner should be installed on the loose side of the belt drive. The following picture shows the tensioner device diagram of the synchronous belt drive. 11. When the synchronous belt is running, it is strictly prohibited for solid substances to be rolled into the tooth groove. Finally, let's learn about the advantages and disadvantages of synchronous belt drive. As shown in the figure, synchronous belt drive is a meshing drive. Although the synchronous belt is an elastic body, due to the characteristic that the load-bearing rope that bears the load in it does not stretch under the action of tension, the pitch of the belt can be kept unchanged, enabling the belt to correctly mesh with the pulley teeth, realizing a synchronous drive without slippage and obtaining an accurate transmission ratio. Since the synchronous belt performs a synchronous drive without slipping, it has a relatively high transmission efficiency, generally up to 0.98. Compared with the V-belt drive, it has obvious energy-saving effects. The transmission ratio of the synchronous belt drive can generally reach about 10, and in the case of a large transmission ratio, its structure is more compact than that of the V-belt drive. Because the synchronous belt drive is a meshing drive, the diameter of its pulley is much smaller than that of the V-belt pulley that relies on friction to transmit power. In addition, since the synchronous belt does not require a large tension force, the sizes of the pulley shaft and bearing can be reduced. Therefore, compared with the V-belt drive, under the same transmission ratio, the synchronous belt drive has a more compact structure. Since the load-bearing rope in the synchronous belt is made of materials such as glass fiber and steel wire with a very small elongation rate, the belt stretches very little during operation, and there is no need to frequently adjust the tension force like the V-belt and chain drive. In addition, the synchronous belt does not require any lubrication during operation, so the maintenance is more convenient, and the operation cost is much lower than that of the V-belt, chain, and gear. Although the synchronous belt drive has the above advantages compared with other drives, it has extremely strict requirements for the center distance during installation and other aspects. Meanwhile, the manufacturing process is complex, and the manufacturing cost is high. The following figure shows the synchronous pulley. Finally, I would like to share a case with you. During the research and development process of the electrostatic removal device for ultralight and ultrafine debris in the tobacco processing workshop of Changde Cigarette Factory of China Tobacco Hunan Industrial Company, Limited, the problem of the easy deviation of the electrostatic adsorption belt occurred, which seriously affected the production efficiency. In order to solve this problem, the technical team of the factory innovatively applied an electrostatic adsorption belt drive structure. They effectively prevented the phenomena of the electrostatic belt deviation, chain disengagement, and tooth skipping during the operation of the device by matching and meshing the mesh chain link plate layer of the electrostatic adsorption belt with the sprocket of the transmission wheel assembly, adding a tension unit, and adding a pressure sensor and a display controller. Meanwhile, it is convenient for the installation of the equipment and realizes the real-time monitoring of the equipment status during operation. Through this case, we hope that you can realize that in engineering practice, in the face of difficulties and challenges, we should have a strong sense of responsibility and the courage to take on the responsibility. At the same time, we should cultivate our innovative spirit and teamwork ability to contribute to solving practical problems. In this lesson, we've studied the key steps such as the overview of transmission technology, ordinary belt drive, and synchronous belt drive. Through the demonstration of the courseware and in-depth thinking, we have not only mastered the relevant skills, but also deeply understood the importance of the sense of responsibility. I hope that in your future study and work, you can continue to carry forward this spirit and make greater contributions to China's engineering technology cause. Finally, please think about this course and complete the following exercise, which aim to consolidate the knowledge points learned today and further deepen your understanding. This lesson ends here. See you next time.